welcome back to the series. Today's a mixed bag. Some crucial resume polishing, a quick project save, and then we dive headfirst into a couple of LeetCode problems. One's a fairly straightforward sums game, and the other, well, let's just say it involves trees and maximizing things. Let's get into it. This is day 50 of coding every day until I hit 1K subs. Halfway to 100 days, which is pretty wild. Thanks for sticking with me on this journey. First up, some quick project maintenance. I push some updates to my resume. You know how it is, always good to keep that document fresh and reflecting the latest and greatest. No major code changes to show here, just good old-fashioned content refinement. Alright, with those updates out of the way, let's switch gears to some LeetCode. I tackled two problems today. First up is problem 2894, divisible and non-divisible sums difference. Spoiler alert. The problem asks us to take two positive integers, and we need to find all numbers from 1 to then. We calculate num1, which is the sum of all integers in that range not divisible by precompute, and num2, which is the sum of integers in that range that are divisible by. The goal is to return num1 minus num2. So this is the code I ended up with. This solution iterates through numbers from 1 to. For each number, it uses the modulo operator to check if the number is divisible by. If it is, the number is added to a running sum called num2, otherwise it's added to num1. Finally, it returns the difference between num1 and num2. This approach is quite direct, leading to an order n time complexity, where n is the input, and it uses order 1, or constant, space complexity. Next up, problem 3372. Maximize the number of target nodes after connecting trees 1. This one's a bit more involved. Spoiler incoming. We're given two undirected trees, represented by edge lists, and an integer. We need to connect one node from the first tree to one node in the second tree by adding a single edge. A node is considered A if the number of edges on the path from the chosen node in the first tree to this target node, which can be in either tree, is less than or equal to. Our task is to find the maximum possible number of target nodes for each node in the first tree, assuming we optimally connect it to a node in the second tree. Alright, here's the Python solution for that tree problem. The core idea is to precompute reachable nodes for both trees. It uses a depth-first search, or DFS, function. This DFS explores each tree from a given starting node to count how many other nodes are reachable within a specified distance for the first tree, and k-1 for the second tree, because one step or is used for the connection between the trees. A helper function constructs adjacency lists and then runs this DFS from every node to get these counts. The main logic then calculates these counts for tree 1 using, and for tree 2 using "(-1). It finds the maximum number of nodes reachable in the second tree. For each node in the first tree, the answer is its own reachable count, plus this maximum from the second tree. This strategy ensures we maximize the target nodes by always picking the best connection point in the second tree. The time complexity involves running DFS from each node, so it's roughly order n times k for each tree, where n is nodes and k is distance, plus iterating to combine results. Space is order n for adjacency lists and storing counts. And that's a wrap for day 50. A bit of project maintenance and two LeetCode problems, one of which definitely made me scratch my head a bit with those tree traversals. It's always satisfying to work through them though. If you enjoyed the video or found it helpful, please do hit that like button, subscribe if you haven't already, and drop a comment down below. Maybe let me know what kind of problems you're working on, or if you have any questions. If you'd like to support the channel further, you can do so over at buymeaboba.com, link is in the description. Every little bit helps me keep this series going. Thanks for watching, and I'll see you in the next one.